Hello and welcome to the JavaScript for Beginners course. My name is Mosh Hamedani and I'm super excited to take you through the ins and outs of learning JavaScript for the first time. This course will teach you the fundamentals of programming and JavaScript. Once you have finished this course, you have taken the first steps towards becoming a skilled front-end developer. Are you ready to dive into JavaScript? Then let's get started. In this 3-minute introduction, I'm going to answer 4 frequently asked questions about JavaScript. What is JavaScript? What can you do with it? Where does JavaScript code run? And what is the difference between JavaScript and ECMAScript? So let's start with the first question. What is JavaScript? JavaScript is one of the most popular and widely used programming languages in the world right now. It's growing faster than any other programming languages, and big companies like Netflix, Walmart, and PayPal build entire applications around JavaScript. And here's the average salary of a JavaScript developer in the United States. That is $72,000 a year. So it's a great opportunity to get a good job out of learning JavaScript. You can work as a front-end developer, or a back-end developer, or a full-stack developer who knows both the front-end and the back-end. Now the second question, what can you do with JavaScript? For a long time, JavaScript was only used in browsers to build interactive web pages. Some developers refer to JavaScript as a toy language, but those days are gone because of huge community support and investments by large companies like Facebook and Google. These days, you can build full-blown web or mobile apps, as well as real-time networking applications like chats and video streaming services, command line tools, or even games. Here's an example. The third question, where does JavaScript code run? JavaScript was originally designed to run only in browsers. So every browser has what we call a JavaScript engine that can execute JavaScript code. For example, the JavaScript engines in Firefox and Chrome are SpiderMonkey and V8. In 2009, a very clever engineer called Ryan Dahl took the open source JavaScript engine in Chrome and embedded it inside a C++ program. He called that program Node. So Node is a C++ program that includes Google's V8 JavaScript engine. Now with this, we can run JavaScript code outside of a browser. So we can pass our JavaScript code to Node for execution. And this means with JavaScript, we can build the backend for our web and mobile applications. So in a nutshell, JavaScript code can be run inside of a browser or in Node. Browsers and Node provide a runtime environment for our JavaScript code. And finally, the last question. What is the difference between JavaScript and ECMAScript? Well, ECMAScript is just a specification. JavaScript is a programming language that conforms to this specification. So we have this organization called ECMA, which is responsible for defining standards. They take care of this ECMAScript specification. The first version of ECMAScript was released in 1997. Then, starting from 2015, ECMA has been working on annual releases of a new specification. So in 2015, they released ECMAScript 2015, which is also called ECMAScript version 6 or ES6 for short. This specification defined many new features for JavaScript. Alright, enough theory, let's see JavaScript in action. So every browser has a JavaScript engine, and we can easily write JavaScript code here without any additional tools. Of course, this is not how we build real-world applications, but this is just for a quick demo. So open up Chrome, right-click on an empty area, and go to Inspect. Now this opens up Chrome Developer Tools. Here, select the Console tab. This is our JavaScript console, and we can write any valid JavaScript code here. So type this, console.log, put a single quote here, and then hello world. Another single quote to terminate, close the parenthesis, and add a semicolon at the end. Now, as you go through the course, you're going to understand exactly what all this means. For now, don't worry about it. So now press enter, and you can see the hello world message on the console. We can also write mathematical expressions here. For example, 2 plus 2, we get 4. Or we can do something like this. Alert, parenthesis, single quote, yo. Enter, and here's an alert. In the next lecture, I'm going to talk about setting up your development environment for writing JavaScript code. In order to write JavaScript code, you need a code editor. There are various code editors out there, including Visual Studio Code or VS Code, Sublime Text, Atom, and so on. Out of these, my favorite is Visual Studio Code that you can download from code.visualstudio.com. It's a very simple, lightweight, cross-platform, and powerful editor. So if you don't have Visual Studio Code on your machine, go ahead and download it. The other thing I want you to install is Node. You can download Node from nodejs.org. Now, technically, you don't necessarily need Node to execute JavaScript because, as I explained before, you can execute JavaScript code inside of a browser or in Node. But it's good to have Node on your machine because we use that to install third-party libraries. And also, later in this section, I'm going to show you a preview of Node. So, pause the video now and download Visual Studio Code as well as Node. Once you're done, come back, continue watching. All right, now I want you to create a new folder. Call that JS-Basics. The name doesn't really matter. We just want to have a folder for writing all the code in this course. Now, drag and drop this folder into Visual Studio Code. Okay, we've got this folder open. Let's add a new file here, index.html. Now, you don't really need to know HTML in order to take this course, but if you want to be a front-end developer, you should know your HTML well. Now, in this file, I want you to type an exclamation mark and then press tab. This generates some basic HTML boilerplate. We don't really care about any of this code here. We're going to use this as a host for our JavaScript code. You're going to see that in the next lecture. So, save the changes. Now, open the extensions tab here. Here in this box, search for live server. So live server is a very lightweight web server that we're going to use to serve our web application. So install this, then you will have to restart Visual Studio Code. When you're done, go to the Explorer tab, right-click index.html, and select Open with Live Server. This will open up Chrome or your default browser and point it to this address. That's where our web application is served from. Now, currently we have an empty page. Now, to make sure that everything is working properly, let's go back to Visual Studio Code. Here in the body section, let's add an H1, press tab, and type hello world. Now, save the changes. Back in the browser, you can see this page is refreshed automatically, and we've got the hello world heading here. In the next lecture, you're going to write your first JavaScript code. All right, now we're ready to write our first JavaScript code. In order to write JavaScript code here, we need a script element. There are two places where we can add a script element. We can add that here in the head section or in the body section. The best practice is to put the script element at the end of the body section after all the existing elements. So here after H1, I'm going to type script and press tab. This is our script element. Now, why did I say that as a best practice, you should put the script element here? Well, there are two reasons for that. One reason is that the browser parses this file from top to bottom. So if you put the script element here in the head section, you might have a lot of JavaScript code there. So your browser may get busy parsing and executing that JavaScript code, and it won't be able to render the content of the page. So this will create a bad user experience. Your user looks at your web page, it's white or blank, while your browser is busy parsing and executing your JavaScript code. So that's reason one. The second reason is that almost always the code that we have in between script elements needs to talk to the elements on this web page. For example, we may want to show or hide some elements. So by adding the code here at the end of the body section, we'll be confident that all these elements are rendered by the browser. Now, there are exceptions to this rule. Sometimes you're using third-party code that has to be placed in the head section. But these are exceptions. As I told you before, as a best practice, you should add your JavaScript code at the end of the body section. Now here, we're going to write the same code that you wrote in the last lecture. Console.log hello world. But we're going to talk about this in a little bit more detail. What we have here is a statement. A statement is a piece of code that expresses an action to be carried out. In this case, we want to log a message on the console. All statements in JavaScript should be terminated by a semicolon. What we have here in between single quotes is called a string. A string is a sequence of characters. Now in JavaScript, we also have this notation. We can add 2 slashes, and this represents a comment. So here we can add some description to our code, and this description is ignored by the JavaScript engine. It's not executed. It's purely for documenting the code when you want to explain to other developers why you have written this code this way. You don't want to explain what the code does because that should be clear in the code itself. So here I don't want to write something like logging something on the console. That's so obvious in the code, right? Instead, we want to explain whys and hows. So for this demo, I'm just going to add a simple comment. This is my first JavaScript code. Now save the changes. Back in the browser, we need to bring the console back up. So right click somewhere and go to inspect, or alternatively, you can use a shortcut that is Alt Command and I on Mac or Alt Control I on Windows. That brings up the console tab. If the console tab is not immediately visible, make sure to select it here. And here you can see the hello world message. Now, while we can easily write JavaScript code in between the script element, in a real-world application, we have thousands or even million lines of code. We don't want to write all that code inline here. We want to extract and separate our JavaScript code from our HTML code. Let me give you a metaphor. Think of your house. In your bedroom, you have your bed and your clothes. You don't store your clothes in the kitchen. This is what we call separation of concerns. We have the same principle in programming. So we want to separate HTML, which is all about content, from JavaScript, which is all about behavior. How should your web page behave? What should happen when we hover our mouse over a given element? Maybe something should pop up, maybe something should be hidden. So we use JavaScript to implement behavior. So open up the Explorer window, add a new file, call it index.js. Now back in index.html, cut all this JavaScript code here and then paste it in index.js. Now in this simple application, we have a single file, a single JavaScript file. In a real-world application, we have hundreds or even thousands of JavaScript files. Later in the course, you will learn how to combine these files into a bundle and serve that bundle to the client. Now, save the changes, back in index.html. Now that all our JavaScript code is in a separate file, we need to reference that file here. So let's add an attribute here, src, which is short for source, and set it to index.js. So this tells the browser that our JavaScript code is now in index.js. Save the changes, back in the browser. You can still see the hello world message, and that confirms that our code is still working. In the next lecture, we're going to execute this code in Node. So in the last lecture, we executed this piece of JavaScript code inside of a browser. In this lecture, I'm going to show you how to run the same code in Node. So I'm assuming that you have installed Node on your machine. If not, head over to nodejs.org and download the latest version of Node. Now, if you're on Windows, open up Command Prompt. If you're on Mac, open up Terminal and head over to the folder you created earlier. Now in this folder, we run Node and pass the name of our JavaScript file, that is index.js. We get the same message on the console. So you can see Node is a program that includes Google's V8 JavaScript engine. We can give it a piece of JavaScript code and it will execute that code for us, just like how we can execute some JavaScript code in a browser. So Node is a runtime environment for executing JavaScript code. Now let me show you a tip. Here in VS Code, we have an integrated terminal, so you don't have to explicitly open up a separate terminal window. So here on the top, under the View menu, look, we have integrated terminal. Note the shortcut here. That's the shortcut for Mac. On Windows, you're going to have a different shortcut. So select this, and here's our integrated terminal pointing to the same folder where we created our files. So you don't have to explicitly navigate to this folder. And here we can run node index.js as well. Now in this course, we're not going to work with Node anymore because Node is a completely separate topic. In fact, I have a comprehensive course about Node with 14 hours of content. So once you finish this course, if you want to learn Node, you can always look at my Node course. Let's start this section by a discussion of variables, which are one of the most fundamental concepts in JavaScript and any other programming languages. In programming, we use a variable to store data temporarily in a computer's memory. So we store our data somewhere and give that memory location a name. And with this name, we can read the data at the given location in the future. Here's a metaphor. Think of the boxes you use to organize your stuff. You put your stuff in various boxes and put a label on each box. With this, you can easily find your stuff, right? A variable is like a box. What we put inside the box is the value that we assign to a variable, that's the data, and the label that we put on the box is the name of our variable. Now let's see this in code. So here in index.js, I'm going to declare a variable. Now previously, in the old days, before ES6, we used the var keyword to declare a variable. But there are issues with var, as you will find out later in the course. So going forward from ES6, the best practice is to use the let keyword to declare a variable. Now we need to give this variable a name or an identifier, and this is like the label we put on a box. So I'm going to call this name, and finally we need to terminate this declaration with a semicolon. Now let's log this on the console and see what we get. So console.log name. Once again, we need to terminate this statement with a semicolon. Save the changes, and here in the console we see undefined. So by default, variables that we define in JavaScript, their value is undefined. Now we can optionally initialize this variable. So I'm going to set this to a string, which is a sequence of characters, like Mosh. Note that I'm using single quotes. You can also use double quotes. Different developers have different preferences, but it's more common to use single quotes for declaring strings in JavaScript. Now, when we save the changes, instead of undefined, we see Mosh on the console. So here in this example, we have declared a variable called name, and we have set that to this value, to this string. Now, we have a few rules for naming these variables. Here are the rules. First is that they cannot be a reserved keyword. So in JavaScript, we have reserved keywords. Let is one of them. We also have if, else, var, and so on. Now, you don't have to memorize this list. If you try to use one of these names, you're going to get an error. For example, if I change this to if, note this red underline. This is indicating that this is not a valid identifier, okay? So revert it back. Now, the second rule is that they should be meaningful. We want to have meaningful names, like meaningful labels. I've seen developers using names like A or B or A1 or I don't know, X. These variable names do not give us any clue what is the purpose of these variables. What kind of data are we storing at that memory location? So always use meaningful and descriptive names, okay? Now, back to name. The third rule is that they cannot start with a number. So we cannot have a variable like one name. But again, going back to the second rule, why would you want to call a variable one name? It's meaningless, right? So always use meaningful names. The fourth rule is that they cannot contain a space or hyphen. So if you have multiple words, you need to put them together. Here's an example. Let's imagine we want to declare a variable called first name. So first name, and note that here I'm using camel notation. So the first letter of the first word should be lowercase, and the first letter of every word after should be uppercase. This is what we call camel notation, which is the convention we use in JavaScript to name our variables. Another thing you need to know about these variable names is that they are case sensitive. So if I declare another variable, call it first name, but make the F uppercase, these two variables are different. But as I told you before, if you stick to camel notation, you wouldn't end up with a variable name like this. And finally, the last thing you need to know about these variables is that if you want to declare multiple variables, there are two ways to do this. You can declare them on one line and separate them using a comma, so first name and then last name. Now in this case, I have not initialized either of these variables. They're both undefined. I can optionally initialize one or both of them. So I can set this to Mosh, and I can leave last name undefined or set it to my last name, Hamedani. But the modern best practice is to declare each variable on a single line. So we terminate this first declaration with a semicolon and declare the second variable on a new line. That's the modern best practice. Next, we're going to look at constants. All right, now let's declare a variable called interest rate. So let interest rate, and we set this to 0.3. Now this is the initial value. We can always change that later. So we can set interest rate to, let's say, 1. Now if we log this on the console, of course we're going to see the new value, right? So save the changes, and here's 1 on the console. However, in a real-world application, there are situations that we don't want the value of a variable to change, because otherwise it's going to create all kinds of bugs in our application. In those situations, instead of a variable, we use a constant. So the value of a variable, as the name implies, can change, but the value of a constant cannot change. So here, if we change let to const, now interest rate will be a constant. So when I save the changes, you're going to see an error in the console on line 3 where we reassign interest rate. So let's have a look. Save the changes, and here's the error. Uncaught type error, assignment to constant variable. You can see this error happen in index.js, line 3. Now if you click here, you can see the line in code where this error occurred. So we cannot reassign a constant. All right, now back to the console. So here's the best practice. If you don't need to reassign, constant should be your default choice. Otherwise, if you need to reassign a variable, use let. So you have learned how to declare and initialize a variable. Now you might be wondering, what are the kind of values that we can assign to a variable? Well, you have seen strings, but we have more types. Basically, in JavaScript, we have two categories of types. On one side, we have primitives, also called value types. On the other types, we have reference types. In this lecture, we're going to focus on primitives, and you're going to learn about reference types later in the course. Now, in the category of primitives, we have strings, numbers, booleans, undefined, and null. Let's look at each of these in action. So here we have a variable called name, which is set to a string. What we have here is what we call a string literal. That's just a fancy name for a string. Now let's declare a variable and set it to a number. So let age, we set that to 30. And by the way, I'm not 30 years old, but don't tell anyone, okay? So this is what we call a number literal. Now let's declare a boolean. A boolean can be either true or false. So let is approved to be true. This is what we call a boolean literal. And we use this in situations where we want to have some logic. For example, if the order is approved, then it needs to be shipped. So the value of a Boolean variable can be true or false. And by the way, note that both true and false are reserved keywords, so they cannot be variable names. Okay? Now you have seen undefined before, so I can declare another variable, first name. If we don't initialize it, by default, its value is undefined. But we can also explicitly set this to undefined. But that's not very common. In contrast, we have another keyword that is null. So let me declare another variable and set this to null. We use null in situations where we want to explicitly clear the value of a variable. For example, we may want to present the user with a list of colors. If the user has no selection, we want to set the selected color variable to null. In the future, if the user selects a color, then we're going to reassign this variable to a color like red. And then if they click red again, perhaps we want to remove the selection, so we set this back to null. So we use null in situations where we want to clear the value of a variable. So these are the examples of primitives or value types. We have strings, numbers, booleans, undefined, and null. Now in ES6 we have another primitive that is symbol, and you're going to learn about that later in the course. One thing that separates JavaScript from a lot of programming languages is that JavaScript is a dynamic language. What do I mean by dynamic? Well, we have two types of programming languages: static languages or dynamic languages. In static languages, when we declare a variable, the type of that variable is set and it cannot be changed in the future. In a dynamic language like JavaScript, the type of a variable can change at runtime. Let's see this in code. So back in the example from the last lecture, we have declared this name variable and we have set that to a string. So the type of name is currently a string, but it can change in the future. Let's take a look. So here in the console, we can execute some JavaScript code. We have this type of operator, and with that we can check the type of a variable. So after that we add the name of the variable, in this case our name variable. So note that the type of name is a string. Now if we reassign name to a different value like a number and check its type, look, the type is now changed to a number. This is what we call a dynamic language. So unlike static languages, the type of these variables will be determined at runtime based on the values that we assign to them. Now let's take a look at a few more examples of the type of operator. And by the way, note that type of is another reserved keyword, so you cannot have a variable called type of. So we can clear the console by pressing Ctrl and L. So now let's take a look at type of age. It's a number. Now if we change age to a floating point number, and I know it doesn't make sense, but let's just stick to this for this example, 30.1. And then look at type of age, it's still a number. So in JavaScript, unlike other programming languages, we don't have two kinds of numbers. We don't have floating point numbers and integers. All numbers are of type number. Now let's look at the type of is approved. It's a Boolean, as I told you before. What about the first name? Let's have a look. Type of first name. It's undefined. And that's funny because the value of this variable is undefined, but its type is also undefined. What does this mean? Well, earlier I told you that we have two categories of types. We have primitives or value types and reference types. In the primitive types category, we have strings, numbers, booleans, undefined, and null. So undefined is actually a type, but is also a value. In this example, because we have set first name to undefined as a value, its type is also undefined. Okay? Now what about selected color? Let's have a look. So type of selected color. The type of this variable is an object. What is an object? That's the topic for the next lecture. So you have seen all the primitive types in JavaScript. Now let's take a look at the reference types. In the reference types category, we have objects, arrays, and functions. In this lecture, we're going to explore objects, and you will learn about arrays and functions later in this section. So, what is an object? An object in JavaScript and other programming languages is like an object in real life. Think of a person. A person has name, age, address, and so on. These are the properties of a person. We have the same concept in JavaScript. So when we're dealing with multiple related variables, we can put these variables inside of an object. For example, here we have two variables, name and age. They're highly related. They are part of the representation of a person. So instead of declaring two variables, we can declare a person object. And then instead of referencing these two different variables, we can just reference the person object. It makes our code cleaner. So let's see how we can declare a person object. We start with let or const if we don't want to reassign the person object, and set it to an object literal. So this syntax we have here, these curly braces, is what we call an object literal. Now, between these curly braces, we add one or more key value pairs. So the keys are what we call the properties of this object. In this case, we want this person object to have two properties or two keys, name and age. So we add name here, that's the key. Then we add a colon, and after that we set the value. So mosh. Now we add a comma and add another key value pair, age 30. So now we have a person object with two properties or two key value pairs, name and age. And with that, we don't need these two variables. Now let's log person on the console. So console.log person. Save the changes. So here's our person object. Again, note the object literal syntax. So we have curly braces, and in between them we have one or more key value pairs. And these are the properties of the person object. Now, there are two ways to work with these properties. Let's say we want to change the name of this person. So we need to access the name property. There are two ways. The first way is what we call the dot notation. So we add the name of our object, in this case person, dot. Now you can see its properties. We have age and name. So we can change the value of name to John. Now we can use the dot notation to also read the value of a property. So here on line 10, instead of logging the person object, we can log its name property. Now save the changes, and in the console we get John. The other way to access a property is using bracket notation. So bracket notation. So instead of dot, we use square brackets, and we pass a string that determines the name of the target property. So single or double quotes, but single quotes are more common. The name of the target property is name. So we can change that to, let's say, Mary. Again, when reading that, we can use the dot notation or the bracket notation. If we save the changes, now we get Mary on the console. Now you might be asking, which approach is better, dot notation or bracket notation? Well, as you can see, dot notation is a bit more concise, it's shorter, so that should be your default choice. However, bracket notation has its own uses. Sometimes you don't know the name of the target property until the runtime. For example, in our user interface, the user might be selecting the name of the target property. In that case, at the time of writing code, we don't know what property we're going to access. That is going to be selected at runtime by the user. So we might have another variable somewhere else, like selection, that determines the name of the target property that the user is selecting, and that can change at runtime. With this, we can access that property using the bracket notation in a dynamic way. So we pass selection here, and we get the same result. Okay? Now, if this is confusing, don't worry. You're going to see this again in the future as you gain more experience with JavaScript. For now, just stick to the dot notation because that's cleaner and easier. Next, we're going to look at arrays. Sometimes in your applications, you might be dealing with a list of objects. For example, the list of products in a shopping cart, or the list of colors the user has selected. In situations like that, you use an array to store that list. Let me show you how. So here I'm going to declare another variable called selected colors. Note that I'm using a meaningful name. I don't have SC or some other weird name. Selected colors. Now we can initialize this and set it to an empty array. So these square brackets are what we call array literal, and they indicate an empty array. Now we can initialize this array and add a couple of items like red and blue. Let's log this on the console. So console, the log, selected colors. Save the changes. So here's our array with 2 elements. We can expand that. Note that each element has an index, and that determines the position of that element in the array. So the index of the first element is 0, and the index of the second element is 1. So if you want to access an element in an array, we use this index. Here's how. For example, let's say you want to display the first element in this array. You use the square brackets and then specify the index. Save the changes, and now we have red. Now, earlier I told you that JavaScript is a dynamic language, so the type of variables can change at runtime. The same principle applies to our arrays. So the lengths of arrays, as well as the type of objects we have in an array, are dynamic. They can change. So on line 2, we initialize this array with 2 elements, right? Now, on line 3, we can add another element to this array, so the array will expand. So let's say selected colors of 2. That means the third item in this array is going to be green. Now, let's display this array on the console. So we have an array with 3 elements. So the length is dynamic. It can change. Also, the type of objects we have in this array is dynamic. So unlike other programming languages where every item or every object in the array should have the same type, in JavaScript, we can store different types in an array. So we can make the last element a number. Save the changes. Now we have 2 strings and a number. So the objects in the array as well as the size of the array are dynamic. Now technically an array is an object. So just like the personal object we defined in the last lecture, it has a bunch of key value pairs or properties that we can access using the dot notation. Let me prove that to you. So here on the console, let's look at the type of selected colors. So the type of this array is an object. So an array is an object in JavaScript. So here on line 4, we can look at the properties of this array or this object using the dot notation. Look, these are all the properties defined in arrays in JavaScript. So every time we declare an array using square brackets, that array will automatically receive these properties. We didn't explicitly define them. They're just somehow magically inherited from somewhere else. We're going to learn about that later when we talk about prototypes. Now in this lecture, we're going to look at one of these properties. That is the length property. This property returns the number of items or elements in an array. So save the changes. You can see we have 3 elements in this array. Now later in the course, we have a comprehensive section about arrays. You will learn about all kinds of operations you can perform on arrays. For now, all I want you to take away is that an array is a data structure that we use to represent a list of items. In the category of reference types, you have learned about objects and arrays. Now let's take a look at functions. Functions are one of the fundamental building blocks in JavaScript. A function is basically a set of statements that performs a task or calculates a value. Let me show you a couple of examples. So I'm going to declare a function using the function keyword. Now we need to give it a name Let's call that greet. After that, we need to add parentheses. That's part of the syntax for declaring functions. And then curly braces. Now what we have here inside the curly braces is what we refer to as the body of this function. And this is where we add all the statements to define some kind of logic in our application. For example, the logic for this function should be to display a message on the console. So here we can add console.log hello world. Now note that here we have a statement, so we terminate it with a semicolon. But when we are declaring a function, we don't need to add semicolon at the end because we are not declaring it like a variable like this. Okay? This is a function declaration, right? So now we have a function. We can call this function like this. So we add the name of the function and parentheses again, and then semicolon to indicate that this is a statement. Save the changes. Now we have hello world on the console. But that's pretty boring. Why would we do this? Let me show you how to make this more interesting. Our functions can have inputs, and these inputs can change how the function behaves. So let's say instead of displaying hello world, we want to display the name of the person here, like hello John. So we can add a variable here in between parentheses. We refer to this variable as a parameter. So this greet function has one parameter called name, and essentially name is like a variable that is only meaningful inside of this function. So inside of this function, we can work with this name variable, but it will not be accessible outside of this function. Now name is an input to this function. So instead of displaying hello world, we can display hello, then add a plus here to concatenate two strings. So we can add name after. Now, when calling the greet function, we need to pass a value for the name variable or name parameter more accurately. So we can pass John here. Now we refer to this as an argument. So John is an argument to the greet function, and name is a parameter of the greet function. That's one of the things that a lot of programmers don't know. They don't know the difference between a parameter and an argument. So a parameter is what we have here at the time of declaration, but the argument is the actual value we supply for that parameter. Okay? Now let's save the changes. So we have hello John. Now we can reuse this function, but with a different input. So we can copy this line here and change John to Mary. Save the changes. Now we have two different messages on the console. Now a function can have multiple parameters. So here we can separate parameters using a comma. So let's add another parameter like last name. Now we can change our console.log, add a space here, and then display the last name. Now, when calling this greet function, we should pass another argument for the last name, right? But let's see what happens if we don't do this. So I'm going to save the changes. See what we got? Hello, John, undefined. Because as I told you before, the default value of variables in JavaScript is undefined. So because we did not pass a value for the last name, by default, it's undefined. So I'm going to pass another argument here. We separate them using a comma, John Smith. And we don't need the second call to the greet function. Save the changes. Now we have hello, John Smith. Now there is a cleaner way to write this code on line 3. All these concatenations are kind of ugly. They're getting in the way. Later in the course, I'll show you how to use template literals to clean up this code. For now, don't worry about it. Let's look at another example of a function. So this function we have here is performing a task. So performing a task. This task is to display something on the console. But sometimes our functions might calculate something. So here is an example of a function that calculates a value. So again, function. Let's call this function square. This function should take a parameter. Let's call that number. Now we need to calculate the square of that number. That is number times number. Just basic math, right? Now we need to return this value to whoever is calling this function. For that, we use the return keyword. That's another reserved keyword, so you cannot have a variable called return, okay? Now, instead of calling the greet function, let's call the square function. So square, we pass 2. Now this returns a value, so we can use that value to initialize a variable. For example, we can declare another variable called number and set it to a square of 2. And then we can display that on the console. Save the changes, so we get 4. Now, in this particular example, we don't necessarily have to declare a separate variable if all we want to do is to display the square of 2 on the console. We can exclude this variable declaration and simply pass square of 2 to console.log. So when the JavaScript engine executes this code, first it's going to call this function, it would get a value and then pass that value to console.log. Let's save the changes and look, we still get 4. Now I have a question for you. How many function calls do you think we have in this code? We have 2 function calls. Square of 2 is one function call. Let me delete this temporarily. But console.log is also another function call, right? Because here we have parentheses. So we're calling the log function, which is defined somewhere, and passing an argument. We can pass a simple string like hello, or we can pass an expression. That expression can be a call to another function like square of 2. Okay? So this is the basics of functions. Again, later in the course, we have a comprehensive section about functions. For now, all I want you to take away is that a function is a set of statements that either performs a task or calculates and returns a value. A real-world application is essentially a collection of hundreds or thousands of functions working together to provide the functionality of that application. So you have learned how to declare variables and constants. Now let's take a look at operators. In JavaScript, we have different kinds of operators. We use these operators along with our variables and constants to create expressions. And with these expressions, we can implement logic and algorithms. So here are the different kinds of operators we have in JavaScript. We have arithmetic operators, assignment operators, comparison operators, logical operators, and bitwise operators. Over the next few lectures, you're going to learn each of these in detail. The first category of operators we're going to look at is arithmetic operators. We use this for performing calculations, just like the calculations we have in mathematics. So here we have 2 variables, x and y. Let's take a look at all the arithmetic operators in JavaScript. So I'm going to do a console.log. Here's the first example, x plus y. That is the addition operator. So these arithmetic operators usually take 2 operands, in this case x and y, and then produce a new value. What we have here, this x plus y, is what we refer to as an expression in JavaScript. So an expression is something that produces a value. So here's the addition operator. We also have subtraction. We have multiplication, division, and remainder of division. So just like the basic arithmetic operators we have in mathematics. We have a new operator in JavaScript that is exponentiation. It's indicated by 2 stars, and that is x to the power of y. So these are pretty straightforward. We have 2 additional arithmetic operators that are a little bit more tricky, so I'm going to focus on those. For now, I'm going to comment out these few lines. You can do that by selecting a piece of code and pressing Command and / on Mac or Control and / on Windows. So these 2 other operators are increment and decrement operators. Let's see how they work. So increment is indicated by 2 plus signs. And depending on where we put the plus signs, this operator will behave differently. So I'm going to do a console.log of x. X is initialized to 10. So if I save the changes, we see 10 on the console. Now, if I put the increment operator before x, the value of x will be incremented by 1 first, and then we will see that on the console. Let's take a look. So save the changes. See, we get 11. In contrast, if we put this operator after x, we'll see x on the console first, and then the value of x will be incremented by 1. Have a look. Save the changes. We see 10, but at this point, x is incremented by 1. So if we do another console.log of x, now we should see 11. Have a look. Here it is. The decrement operator is pretty similar. So instead of 2 plus signs, we have 2 minus signs. And here I'm going to apply this before x. So we're going to decrement the value of x by 1 and then display it on the console. So for this demo, I'm going to comment out these 2 lines. Have a look. We see 9 on the console because we applied this operator first and then displayed x on the console. So these are all the arithmetic operators we have in JavaScript. To recap, we have addition, subtraction, multiplication, division, remainder of division, exponentiation, which is x to the power of y, as well as increment and decrement operators. The second category of operators we're going to look at is assignment operators. You have already seen an example of an assignment operator. So here we are using the simple assignment operator to assign a value, in this case 10, to x. But we have a few more assignment operators. Let me show you. So in the last lecture, you learned about the increment operator. With this, we increment the value of x by 1. This expression here is exactly equivalent to this. So we read the value of x, add 1 to it, and then using the assignment operator, assign this new value to x. But what if in this example, instead of adding 1 to x, we want to add, let's say, 5? Well, this increment operator will not work. So how can we do that? Well, this is one simple way, but we have a shorthand. We can use the addition assignment operator like this. So line 5 and line 4 are exactly the same. Here's another example. Let's imagine we want to multiply the value of x by 3. So we can write it like this, x equals x times 3, or we can use the multiplication assignment operator like this. So all the other arithmetic operators you learned about in the last lecture, addition, subtraction, division, multiplication, and the remainder operators, all of them have this combination with the assignment operator. All right, now let's take a look at comparison operators. As the name implies, we use these operators to compare the value of a variable with something else. So here we have x set to 1. Let's look at the first comparison operator, that is greater than. So we want to check if x is greater than 0. I'm going to save the changes. Look what we get, true. So the result of an expression that includes a comparison operator is a Boolean. It's true or false. Now, let's look at another example. This second operator is greater than or equal to. So we can change 0 to 1 to see if x is greater than or equal to 1. Obviously it is, so if we save the changes, we get true again. The other operators are very similar. So we have less than, as well as less than or equal to. Now let's save the changes. Look at what we get on the console. So the third item is false because x is not less than 1. It's less than or equal to 1. That's why we got false here. So these 4 operators we have here, we refer to them as relational operators. We also have equality operators. So we can check to see if x is equal to 1. So we have triple equal signs. Let's save the changes. Obviously, x is 1. That's why we get true. Now, if you want to check if x is not equal to a given value, you replace the first equal sign with an exclamation mark. So let's save the changes. The result of the last expression is false because x is equal to 1. So these are all the comparison operators in JavaScript. In the last lecture, you learned about the equality operator. Now, technically in JavaScript, we have another equality operator that is indicated by 2 equal signs instead of 3 equal signs. So you might be wondering what the difference is. Well, first of all, what we have on the top is what we refer to as strict equality operator. What we have on the bottom is what we call loose equality operator. Now, this strict equality operator ensures that both these values we have on the sides of this operator have the same type and the same value. What do I mean by that? Well, in this example, on both sides of this operator, we have 2 numbers. So their type as well as their value are equal. So if we save the changes, we get true and true. Now, let's take a look at another example. This time, I'm going to change one of these numbers to a string. Now, if I save the changes, this expression is going to evaluate to false because here we're comparing a string with a number. So the types here do not match. That's why we'll get false. Let's have a look. Save, and here's false, right? So the strict equality operator ensures that both operands are of the same type and have the same value. Now, loose equality operator behaves differently. So to focus on this operator, I'm going to comment out these 2 lines. So here we're comparing 1 with 1, and we get true. Now, what if we compare 1 as a string with 1? We will still get true. In contrast, in the previous example, we got false. So let's see what's happening here. In this case, this operator looks at the value on the left side. Here we have a string. So it will automatically convert what we have on the right side to a string. So it will look like this. And now, because these values are exactly the same, we get true on the console. Now, what if on the left side we have a Boolean? Well, this operator looks at what we have on the left side. Because it's a Boolean, it will automatically convert the value on the right side to a Boolean. So it's like comparing true with true. And if we save the changes, again, we get true. So here's what you need to take away. The strict equality operator ensures that both values have the same type and the same value. The loose equality operator doesn't care about the types matching. If the types don't match, it will convert the type of what we have on the right side to match what we have on the left side. And then it will only check if the values are equal. Now, most of the time, you should be using the strict equality operator because it's more precise and accurate. Now let's take a look at the ternary or conditional operator, which is one of my favorite operators in JavaScript. Let's imagine we want to implement a rule like this. If a customer has more than 100 points, they are a gold customer. Otherwise, they are a silver customer. How do we implement this? Well, first I'm going to start by declaring a variable to keep track of the number of points. So let points, we set that to, let's say, 110. Now we want to declare another variable called type that represents the type of customer. And here is where we use the ternary or conditional operator. So this is how it works. First, we start with a condition. We want to compare the number of points with 100. So we use the comparison operator here, points greater than 100. Now, as you learned earlier, this expression produces a Boolean. So the result of this expression is either true or false. Now, depending on the result, we're going to set this type variable to a different value. So here we add a question mark. Now, if this expression evaluates to true, that means this is a gold customer. So we want to set type to gold. Otherwise, if this expression evaluates to false, we want to set the type to silver. So this is the ternary or conditional operator. We start with a condition. If that condition evaluates to true, we will use this value. Otherwise, we'll use this other value. Now, let's log type on the console. Save the changes. So we have a gold customer. In contrast, if I change the number of points to 90 and save the changes, we'll get a silver customer. All right, now let's take a look at the logical operators. We use these operators to make decisions based on multiple conditions. In JavaScript, we have three types of logical operators: logical AND, logical OR, and NOT. Let's see each of these operators in action. So I'm going to start with the logical AND, which is indicated by two ampersands. So here's the basic rule of thumb. This logical AND returns true if both operands are true. What do I mean by that? Well, let's do a console.log true and true. So we have two operands, they're both true. So the result of evaluating this expression will be true. Let's have a look on the console. Look, here we get true. Now, if either of these is false, the result will be false. So I'm going to change this to false, save the changes. Note that we get false on the console. It doesn't matter which one is false. If I make the other one false or both of them false, we'll still get false. So logical AND returns true if both operands are true. Now you might be asking, what is a real-world use case for this operator? Well, let's imagine we want to build an application for approving loans. So we want to see if the applicant has high income and good credit score, then they will be eligible for loan. So I'm going to delete all this and declare a couple of variables. High income, we're going to set that to true, and good credit score, we're going to set that to true as well. So here we're dealing with two conditions. We want to make sure that the applicant has high income and good credit score. That's where we use the logical AND. So we can declare another variable, eligible for loan. And this is where we use the logical AND operator. So high income and good credit score. Now, if we log this on the console, eligible for loan, we should get true. And here's the result. Now let's take a look at the logical OR. So logical OR is indicated by two vertical lines. And this returns true if one of the operands is true. It doesn't matter which one, whether the one on the left or the one on the right or both of them. As long as we have one true operand, the result of this expression will be true. So here's an example. I'm going to replace this logical AND with logical OR. Now in this case, both operands are true, so the result of this expression will also be true. Let's have a look. So I'm going to save the changes. We get true. Now if I change one of these to false, we still get true. It doesn't matter which one is true. As long as we have one operand in this expression that evaluates to true, the result of this expression will also be true. So this is how we use the logical OR. And finally, let's look at the NOT operator. That is indicated by an exclamation mark. So let's imagine if the applicant is not eligible for loan, we want to consider their application as refused. So we can declare another variable, application refused. Here we use the NOT operator. We apply it on eligible for loan. So this is what happens here. If eligible for loan is true, this not operator will convert that to false. So whatever we give it, it will give us the opposite. In this case, if eligible for loan is true, this will convert that to false, and application refused will be false. Because if someone is eligible for loan, we don't want to refuse their application, right? So application refused is always the opposite of eligible for loan. And that's where we use the not operator. So let's see this in action. I'm going to change both these conditions to false. So we're dealing with someone who has low income and bad credit score. Obviously, they are not eligible for loan. So let's log this on the console. Eligible for loan. And we can also add a label. So I'm going to add a string eligible. And here we add comma. Then we apply the not operator to set the application refused variable. Let's do another console.log application refused. And here we log application refused variable. Now let's see what we get on the console. So save the changes. You can see this applicant is not eligible because eligible is false, and application refused is true because it's always the opposite of eligible for loan. In the last lecture, you learned about logical operators. In all the examples you saw in the last lecture, we use these logical operators with Boolean values. But in JavaScript, unlike many other programming languages, we can use these logical operators with non-Boolean values. And that's extremely powerful. Let me show you a few examples. Let's say we have false or true. What do you think is the result of this expression? Well, it's true, right? Now, what if we have false or the string mosh? What do you think is the result of this expression? Well, let's take a look. We get mosh back. What if we have false or number 1? We get number 1 back. So here's the first thing you need to realize. The result of a logical expression is not necessarily a true or false. That depends on the value of the operands we have. In the first example, our second operand is true. That's why we get true back. In the second example, our second operand is a string. That's why we get a string back. And by the same token, in the third example, we get a number back. So when our JavaScript engine tries to evaluate this expression, it looks at each operand. If that operand is not a Boolean true or false, it will try to interpret it as what we call truthy or falsy. So in JavaScript, we have these values which we refer to as falsy. That's not a Boolean false, it's falsy. What are these falsy values? Well, we have undefined, null, number 0, the Boolean false, an empty string, and not a number. Now, we haven't talked about this yet. That's going to come later in the course. For now, just remember, not a number is a special value in JavaScript. And when we're dealing with a mathematical calculation that does not produce a valid number, this value is returned, not a number. Now, we're going to look at that later in the course, so don't worry about it. So these are the falsy values in JavaScript. If we use any of these values in a logical expression, they will be treated as falsy, which is kind of like a Boolean false, but it's not exactly the same. Now, anything that is not falsy is truthy. So, back to these examples. In the second example, our second operand is a string with 4 characters. So this is not an empty string, it's not falsy, so it's truthy. So when our JavaScript engine tries to evaluate this, it looks at the first operand, it's false, so the search continues. Because with the logical OR operator, as you learned in the last lecture, as long as one of the operands is true, the result will be true. Now here in our second example, the first operand is false, so the search continues, hoping that maybe the other operand is true or truthy. In this case, we're dealing with a truthy value, so this value is immediately returned. The same goes for the third example. So here 1 is not a Boolean true, it's truthy. That's why the value of this operand is returned. Now, what if we have an expression like this? False or 1 or 2. What do you think we're going to get? Let's take a look. We get 1. So this is another thing you need to understand about the logical OR operator. The evaluation starts here. As soon as we find an operand that is truthy, that operand is returned. So here our second operand is truthy, its value is returned, and here the evaluation stops. It doesn't matter what we have on the right side. We could have a million other operands, they are completely ignored. This is what we call short circuiting. Short circuiting. Just exactly like short circuiting that we have in electricity. Now that you understand how these logical operators work with non-Boolean values, let me give you a real-world example of when to use this. So, let's imagine we're building an application and somewhere the user has to pick a color, or we're going to use a default color. Maybe this is the color of the t-shirt they want to buy. So I'm going to declare a few variables. User color, we set that to red. Default color, we set that to blue. And current color, which we set to user color or default color. Now let's read this expression in plain English. User color or default color. That basically means if we have a value for user color, we're going to use that. If we don't, we're going to use the default color. Now let's log this on the console. So current color, we get red because our user has selected a color. In contrast, if the user has not selected a color, let's set this to undefined, save the changes, we get blue because default color is blue. So this is the power of using the logical OR operator between non-Booleans. With this technique, we can provide default values. So if the user has selected a color, we're going to use that. Otherwise, we're going to use our default color, and that determines the current color, which we're going to display on the screen. Finally, the last group of operators we're going to look at is bitwise operators. Now, this really requires me to go beyond the scope of this course. I have to talk about some computer science stuff, and honestly, I don't really want to bore you because these stuff don't really have that much of practical usage in the real world. I'm not saying they're useless, they definitely have their own use, but they're more on the theoretical side and it's not something that you will use on a daily basis. However, if you're really enthusiastic, I'm going to explain what these bitwise operators are and how they work, but feel free to skip this lecture if you just want to focus on the practicality. So, you know that we humans use the decimal system to represent numbers. So 1, 2, 3, 4, 5. But in computers, these numbers are stored in the binary format, which is a combination of zeros and ones. So let's take a look at a few examples. The number 1 in the decimal system is represented as 7 zeros, 1, 2, 3, 4, 5, 6, 7, and a 1. So we have 8 digits. Each digit is what we call a bit. So here we have 8 bits, which represents 1 byte of information in a computer. Here's another example. Number 2 in the decimal system equals to 6 zeros and then 1 0. There are mathematical formulas behind this for converting numbers between decimal and binary systems. If you don't want to learn the mathematics, you can simply Google decimal to binary converter. Now, bitwise operators in JavaScript or any other programming languages are similar to logical operators, but they work on the individual bits of a number. Let me show you what I mean by this. So I'm going to do a console.log 1 or 2. Note that here we have a single vertical line that represents a bitwise OR. So bitwise OR. Logical ORs have double vertical line. Okay. So when we apply the bitwise OR between 1 and 2, this is what's going to happen. So I add R as the result here. Now, this operator is going to look at each of these bits like this in a vertical way. If either of these bits is 1, the result will be 1, otherwise it will be 0. So here, in both these numbers, the first 6 bits are 0. So in the result, we'll also have 6 zeros. Now, the 7-bit will be 1 because here we have 1 at this position, right? And similarly, the 8-bit will be 1 because here we have a 1. Now, if you convert this binary number to a decimal number, the result will be 3. So let's save the changes. And you can see on the console we have 3. Bitwise AND is similar. So let's duplicate this. Bitwise AND, we'll use a single ampersand for that. Now, the result is going to be something like this. So if both numbers are 1, 1 will be returned. Otherwise, the result will be 0. So in this case, all the bits will end up being 0. Because if you look at these two first numbers, 1 and 2, their first 6 bits are 0. And here in the second number, we have this bit that is 1, but the bit at the equivalent position here is 0. So if we apply the bitwise AND between these two bits, the result will be 0. Okay? So this binary number equals 0 in the decimal system. Let's save the changes and see this on the console. Save. Here it is. So this is the fundamental of bitwise operators. Now in JavaScript, we have a few more bitwise operators, but in the real world, they're not that common. Now let me give you a real world example of when we can use these bitwise operators, so at least they make sense to you. Imagine you want to implement an access control system. So the user can have these permissions: read, write, and execute. Now we can use 1 byte of information, or 8 bits, to determine the kind of permission a user can have. For example, we can use 5 zeros, 1, 2, 3, 4, 5. We don't care about the first 5 bits, but for the other 3 bits, if the user has a permission, we will use 1, otherwise we'll use 0. So if the user has only the read permission, we will use 1 for the read, and for write and execute, we will use 0. Similarly, if the user has read and write permissions, we can represent this permission using this binary number. And finally, if the user has all these permissions, we can represent that like this. Now, this is where we use bitwise operators. So I'm going to delete these 2 lines as well as these few lines on the top. Let's see how we can implement this access control system using bitwise operators. So I'm going to define a constant called read permission. Now I need to set this to a decimal number that is equivalent to this binary number. That decimal number is 4. Again, you can use an online converter to get this. Similarly, I'm going to define another constant, write permission. Now what I want now is the decimal representation of this binary number. So all these bits or flags are off, only the write flag is on. Okay, so this binary number 10 is equivalent to 2 in the decimal system. And finally, execute permission. So what we want is the decimal representation of this binary number. All these flags are 0, only the execute flag or the execute bit is 1. And that number is 1. Now, I can declare a variable like my permission, initially set that to 0. Now I can give myself extra permissions. So I can update my permission like this. My permission, here we applied the bitwise OR to add a permission, like read permission, as well as the write permission. Okay, now let's take a look at the value of my permission on the console. So we get 6. Now technically, we don't care about this decimal number. We can use the bitwise AND operator to see if I have a given permission. So here's an example. I'm going to declare a variable. Let's call that message. Now here I'm going to use the ternary operator, the conditional operator. Remember? So we start with a condition. We take my permission and use the bitwise AND operator along with the read permission. Now, if this evaluates to true, that means I have the read permission. So let's say we want to display a message like yes, otherwise we want to display no. Let me break this up into multiple lines so you can see clearly. So here's our ternary operator. We have a condition. If that value is true, this value will be used. Otherwise, this other value will be used. Finally, let's log this message on the console. So I have the read permission. But if I remove this read permission here and save the changes, now you can see my read permission is gone. So here's what I want you to take away. With the bitwise OR operator, we can add permissions. And with the bitwise AND operator, we can check to see if we have a given permission. Of course, this is just one real-world use case for using the bitwise operators. There are other use cases, but as I told you before, they're really not that common. So if this lecture was confusing, don't worry about it. When working with complex expressions, one thing that you need to count for is the precedence of operators. Let me show you an example. So let's declare x and set it to 2 plus 3 times 4. What do you think is the result of this expression? Well, let's log this and have a look. So we get 14. The reason for that is because the multiplication operator has higher precedence. So this expression is evaluated first. So 3 times 4 is 12, and then the result is added to 2. Now, all these operators you have learned in this section, they have their own precedence. It's really hard to memorize which operators have higher precedence or lower precedence. So when working with complex expressions, you can use parentheses to determine how these operators are applied. For example, here we can put parentheses around 2 plus 3, and this means this expression is evaluated first, so we get 5, and then the result is multiplied by 4. So now if I save the changes, we get 20. All right, let's finish this section with a simple programming exercise. Let's declare two variables. A, we set it to red, and B, we set it to blue. Now, when we log this on the console, obviously we're going to get red and blue, right? Now, what I want you to do is to write some code here to swap the value of these two variables. So when we log this on the console, instead of getting red and blue, we're going to get blue and red. So pause the video, spend a couple of minutes on this exercise. When you're done, come back, continue watching. All right, to swap the value of two variables, we need a third variable. So we're going to declare another variable. Let's call it C. We're going to use that as a backup. So whatever we are storing in A, we're going to put that in that other variable that is C. Then we're going to copy B to A. And finally, what we have in C, which was the value of A before, we're going to copy that to B. Let me show you. So we declare C and set it to A. So what we have in A, which is red, will be copied to C. Now we want to overwrite A with B. So we said A to B. The value of B is copied to A. Now both these variables at this point are blue. Now finally, we're going to copy what we have in C, which is the original value of A. We're going to copy that to B. So we said B to C. Now, when we save the changes, instead of red and blue, we're going to see blue and red. So this proves that we have swapped the value of these two variables. Now, if you couldn't do this exercise, don't worry. This is because you have not trained your programming brain. And this requires a bit of time. Just like someone who wants to go to gym, they're not going to build muscle on day one. It requires time and effort. Now, to help you train your programming brain, I have designed lots of exercises for you in this course. So as you go through these exercises and look at my solutions, you start to pick up some patterns and techniques to solve programming problems. So once again, if you couldn't do this exercise, don't get disappointed. That's perfectly fine. In the last section, you learned about expressions and operators. In this section, we're going to use these expressions and operators along with conditional statements to implement interactivity in our applications. In JavaScript, we have two types of conditional statements. We have if and else and switch and case. You're going to learn about if and else in this lecture, and we'll look at switch and case in the next lecture. So imagine in our application, we're going to get the current hour, and depending on its value, we're going to greet the user with a different message. So if the hour is between, let's say 6 a.m. and 12 p.m., we're going to display something like good morning. Similarly, if it is between 12 p.m. and 6 p.m., we're going to display good afternoon. Otherwise, we're going to display good evening. So we want to have some logic like this in our application. That's where we use if and else. So we start with if, then we add parentheses, and in between these parentheses, we add a condition. If this condition evaluates to true, the statement that we put after will be executed. Now, if we have multiple statements, we need to put them in between these curly braces. We refer to these as a block of code, okay? Now, optionally, we can have another condition. So we write else if, once again, parentheses, another condition. Now, if this condition is true, then this other statement will be executed. And similarly, if we have multiple statements, we need to surround them with curly braces, like this. Also note that, as a convention, when we want to define a block of code, we put the first curly brace on the same line, not here. That's kind of ugly in JavaScript. So take that into account. Now back to our if and else. We could have yet another condition like this, yet another condition. We can have as many conditions as we want. There is no limitation. And once again, here we can have one or more statements. Now, optionally, if none of these conditions evaluate to true, we can use else to execute one or more other statements. So this is the basic structure. Now, we want to get this logic and map it into this structure. It's very easy. So let's start with our first condition. If hour is between 6 a.m. and 12 p.m., so that's the condition, and the statement we want to execute is good morning, okay? So I'm going to declare a variable here, hour, and set it to 10. Now in a real-world application, we want to read the current hour. For now, let's not worry about getting the current time and just hard code this number here, 10, okay? So we want to compare the value of hour with these two numbers. Now for simplicity, let's go with 24-hour time format. So we want to see if hour is greater than or equal to 6 and hour is less than 12. You learned this in the last section, right? So here we're using these comparison operators. We have two expressions. Here's the first one, here's the second one, and we're applying the logical AND in between them. So if both these expressions evaluate to true, then the result of this expression will also be true. Now let's add the statement. We want to display good morning. And of course, we need to terminate this statement with a semicolon. Now here's my suggestion for you. If you want to master JavaScript, pause the video now and continue implementing this logic using if and else. Then come back, continue watching, and see my solution. All right, let's continue. Here's the second condition. We want to check to see if hour is between 12 and 18. So very easy. If hour is greater than or equal to 12 and it's less than 18, we want to display good afternoon. So console.log good afternoon. Now in this example, we don't need this other else if because otherwise we want to display good evening. So let's delete this. Otherwise we do a console.log of good evening. Now in this example, because we're dealing with a single statement, these curly braces are getting in the way and creating noise in the code. So it's better to get rid of them and simplify the code. Here's another pair. Okay, that's better. Now save the changes. We get good morning here. If I change the hour to 13, we get good afternoon. And if I change this to 20, we get good evening. So this is all about if and else. In the next lecture, you're going to learn about switch and case. All right, now let's take a look at switch and case. So let's start by declaring a variable called role. Let's imagine this represents the role of the current user. Now we want to see if this user is a guest or a moderator or an admin. We can easily implement this logic using a bunch of if and else statements. But there is another way, using switch and case. So let's have a look. We start with this switch statement. We add parentheses, but instead of adding a condition here, we add a variable. In this case, we're going to add the role variable. Now we add curly braces. Then we add one or more case statements. Each case statement is used to compare the value of this variable with something. So here's our first case. If this role equals guest, so I'm comparing the value of role with guest. Now we add colon, and then after that we add one or more statements. So we can do a console.log guest user like this. Now here we need to add the break statement. So we jump out of this switch block. Otherwise, the other statements here will be executed. Let me show you. So we need to add another case statement. If this user is a moderator, we want to display console.log moderator user. Once again, we need to add the break. So in this case, if I don't add this break statement here and the role equals guest, both these console.log statements will be executed. That's why we need to add a break to jump out of this switch block, right? Now, we can have as many case statements here. There is no limitation. Optionally, if none of these cases are matched, we can have a default statement and execute one or more statements. So console.log unknown user, or more accurately, unknown role. Now here for the default statement, we don't need a break because at this point, the control would automatically get out of this switch block, right? So let's save the changes and see what we get on the console. Save. We get unknown user because I have not initialized role, so its default value is undefined and it doesn't match any of these case statements. Now if I change this to guest, save the changes, we get guest user, and similarly if I change it to moderator, we'll get the moderator user message. So here's the takeaway. With switch and case, we can compare the value of a variable against a bunch of other values. Now, they don't have to be a string, they can be numbers or even booleans, but using booleans here is less common because if you want to compare the value of a variable with true or false, it makes more sense to use an if statement. Now, just to let you know, we can implement this exact logic using if and else statements. Let me show you. So if role equals guest, note that I'm using strict equality here, so triple equal signs, and that means we're checking the type and the value of this variable against what we have on the right side. So if role is guest, we want to do a console.log of guest or guest user, else if role equals moderator, then we're going to do a console.log of moderator. Finally, else, if the role is something else, we want to display unknown user. Now compare these two implementations. You can see implementing this logic with if and else is cleaner and shorter. We don't have all these break statements or default or these curly braces. These are extra noise in the code. So it doesn't mean you should never use switch and case. Well, it depends who you ask. I personally tend to use if and else more often. Switch and case are kind of outdated. They look a little bit ugly in my personal opinion. But there's nothing terribly wrong with them. Sometimes they're more explicit. It comes back to your personal preference. Sometimes we want to repeat an action a number of times. For example, let's imagine we want to display hello world 5 times on the console. The poor way of doing that is like this. So console.log hello world, and then repeat it 5 times. This code is ugly. There is a better way to achieve the same result, and that's where we use loops. In JavaScript, we have various kinds of loops, and all these loops essentially do the same thing. They repeat an action a number of times. We have for loops, while loops, do while loops, for in loops, and for of loops. All these loops essentially do the same thing, but there is a subtle difference between how they start and end. Let's start by looking at the for loop. So back to this code. This is how we write a for loop. So for, we add parentheses. Now here we need 3 statements. The first statement is what we call the initial expression. And here we declare and initialize a variable. So we use let to declare a variable like I and set it to 0. Now I is short for index and is a common convention to use in for loops. This is what we call the loop variable. So we initialize it to 0, then we terminate this statement with a semicolon. Now the second part of the for loop is what we call a condition. So here we want to add a condition and compare the value of I with something else. This loop will run as long as this condition evaluates to true. So if we want this loop to run 5 times, we compare I with 5. So as long as I is less than 5, this loop will execute. You will see that in a second. Once again, we terminate this statement with a semicolon. And finally, the third part. This is what we call increment expression. And quite often, what we have here is something like this. So we use the increment operator to increment the value of I with 1. Now, after this for statement, we can add 1 or more statements, just like the if statements. If you have multiple statements here, we need to put them in a code block like this. Now here, we want to display hello world on the console. So our statement is console.log hello world. So instead of repeating this line 5 times, we put it in a for loop, and this loop will run 5 times. Now save the changes. So we get 5 hello world messages on the console. All right, now that you have seen a for loop in action, let's see exactly how this loop works. So earlier I told you this is what we call an initial expression. Here we're initializing I to 0. Now this loop will execute as long as this condition is true. So as long as I is less than 5, the statements we have here will be executed. Now, after the first iteration, I is incremented by 1. Then this condition is evaluated again. So 1 is less than 5. So one more time, this loop is executed. So we have the second iteration. Now after the second iteration, once again, I is incremented by 1. So now we are in the third iteration. Again, this condition is evaluated, and because it is true, the loop is executed. To show you this in action, I'm gonna output I on the console. So save the changes. This is what we get. So note that in the first iteration, I is 0, then it's incremented by 1 until it reaches 4. So at the end of 5th iteration, I will be 4. And when we increment that by 1, it will be 5. So this condition will evaluate to false. So essentially, there are 2 ways to repeat an action a number of times using the for loop. Let's say we want to repeat something 5 times. We can initialize I to 0 and check to see if it's less than 5. Alternatively, we can initialize this to 1 and check to see if it's less than or equal to 5. Now, if we save the changes, you can see I starts from 1 and finishes at 5. Now, we can make this program a bit more interesting. Let's say we want to display the odd numbers between 1 to 5. So instead of logging hello world on the console, we can have an if statement and check the remainder of the division of I by 2. So if the remainder of division of I by 2 is not 0, that means I is an odd number. So we can display it on the console. Save the changes. So here are the odd numbers between 1 to 5. There is also another way to write this loop. Instead of starting from 1 and going all the way up to 5, we can start from 5 and go back to 1. So we change the initial expression, set I to 5. As long as I is greater than or equal to 1, now we want to decrement I. Save the changes. Now we get the odd numbers in the reverse order. Now it's more common to use the previous form, so we initialize I to 0 or 1 and increment it in every iteration. But in certain problems, you want to use a for loop in the reverse order. In the last lecture, we wrote this for loop to display all the odd numbers between 0 and 5. Now in this lecture, I'm going to show you how to implement the same logic but using a while loop. Now one key difference between a while loop and a for loop is that in for loops, the loop variable is part of the loop itself. But in while loops, we have to declare this variable externally. Let me show you what I mean. So we start with declaring a variable like I and set it to 0. Note that this I we have here is different from the I we have in this for loop because this variable is only meaningful and accessible inside of this for loop. This is called scope, and I'm going to talk about it later in the course. All I want you to know is that these two variables are completely different even though they're named the same. Now, we have our loop variable initialized to 0. Next, we add a while statement. In parentheses, we need to add our condition. What is the condition here? That is I less than or equal to 5. So I'm going to add that here. Next, we need to add our statements. So what is the statement that we want to repeat? Here's the statement. We want to display the odd numbers. So we add that here as well. And finally, at the end of this while block, we need to increment I. So this is a direct translation of this for loop into a while loop. So this is what happens when we execute this code. Initially, I is 0. Now, in the while loop, first, this condition is evaluated. If this condition is true, then the body of the while loop will be executed. Again, in the next iteration, the condition is evaluated again. If it's true, the statements in the while block will be executed. Otherwise, the while block will terminate. In the next lecture, we're going to look at another kind of loops in JavaScript. All right, now let's take a look at the third kind of loop we have in JavaScript. That is a do-while loop. Do-while loops are very similar to while loops, but they're slightly different. It's easier to show you in code. So I'm going to rewrite this logic using a do-while loop. Just like the while loops, we have to declare our loop variable externally. So we declare I and initialize it to 0. Okay, now if we save the changes, we're going to get an error. Identifier I has already been declared. Because I have declared I here, so I cannot redeclare it here. This is different from the I that we have in the for loop. Again, this is all about scoping, and I'm going to talk about that later in the course. So to make this work, I'm going to temporarily comment out these few lines and rewrite this logic using a do-while loop. So we add the do statement here, then a code block. In this block, we should have our statements. So I'm going to borrow them from our while loop, copy these, paste them here. And then finally, at the end of this block, we add the while statement along with our condition. That is I less than or equal to 5, followed by a semicolon. Now you might be wondering, what is the difference between a while loop and a do-while loop? Do-while loops are always executed at least once, even if this condition evaluates to false. Let me show you what I mean. So I'm going to temporarily comment out these few lines and bring back our while loop. Also, we don't need this for block for now, so let's comment it out. Now, if we save the changes, we get 135 on the console. However, if I change I to 9, we're not going to see anything. Because the first time we try to execute this while loop, this condition evaluates to false. So these statements are never executed. So save the changes. Look, there's nothing in the console. So in while loops, this condition is evaluated ahead of time at the beginning of every iteration. In contrast, in do-while loops, this condition is evaluated at the end. And that means these statements are always executed at least once, even if the condition is false. So let's try this. I'm going to comment out this while loop and change I to 9, just like before. Save the changes. We get 9 on the console. Why? Because in our do while loop here, on line 15, we check to see if this is an odd number. It is, so we display it on the console. Next, we increment I by 1, so I is 10. Then the condition is evaluated. Of course, it's false, so our loop will terminate. Now, realistically, you're not going to use this do while a lot in programming. There are situations you may want to use this, but in practical terms, most of the time you'll be using a for or a while loop. Just be aware of the difference between a while loop and a do while loop. When writing loops, something that you need to be aware of is what we call an infinite loop. So an infinite loop, as the name implies, executes infinitely or forever. So if you accidentally create one of these loops, you're going to crash your browser or your computer. Let me show you an example. So here I'm going to declare a variable, set it to 0, put it in a while loop. So as long as I is less than 5, we're going to do a console.log of I. Now here technically we should increment I, but if we forget to do so, we end up creating an infinite loop. Because in the first iteration, I is 0 and it's less than 5, so we'll display I on the console. Now in the second iteration, I is still 0 and is less than 5. So this loop will run forever. Let me show you. So I'm going to save the changes. Now on the console, this number you see before 0 is the number of times we're displaying 0 on the console. So you can see this number is increasing rapidly. So far we have displayed 0 more than 3,500 times. And if you look at the browser, you can see this spinner going forever. So the only way to get rid of this is to close this window, or if this doesn't work, you'll have to force quit Chrome. So this is one example of an infinite loop. Here's another example. While true. Again, this loop is going to run forever, so it's an infinite loop. And by the way, infinite loops are not limited to while loops. We can create an infinite do while loop. So do while true. Or similar to the last example, maybe we'll create a loop variable like 0 and then have a condition like x is less than 5, but we forget to increment x here. We can also create an infinite for loop. So for let I equal to 0. As long as I is greater than 0, I plus plus. Again, with the condition that we have placed here, this loop is going to run forever. Or maybe we have the right condition, like I is less than 10, but we forget to add the third part. So we don't increment I. And this is exactly like this while loop that we had earlier, without incrementing I. So be aware of the infinite loops, avoid them, because they can crash your browser or your computer. So far you have learned about 3 kinds of loops in JavaScript: for loops, while loops, and do while loops. With all these loops, we can repeat an action a number of times. But we have 2 more kinds of loops in JavaScript, and we use them to iterate over the properties of an object or elements in an array. Let me show you. In this lecture, we're going to look at the for-in loop. So let's say we have an object like person with 2 properties, name, mosh, and age 30. Let's say we want to display all the properties of this person object. That's when we use the for-in loop. So for, now in parentheses, unlike the for loop that we learned about earlier, we don't have 3 parts. So we don't have that initial expression followed by semicolon, a condition followed by the increment part. It looks a little bit different. Let me show you. So we have let key in person. So in every iteration, this key variable in the loop will hold the name of one of the properties in this person object. Let me show you. So here I'm going to do a simple console.log of key, save the changes. So in the first iteration, key is name, and in the second iteration, it is age. Now, what if you want to display the value of each property next to it? Well, earlier I told you that there are two ways to access the properties of an object. We can use the dot notation, which looks like this, person.name, or we can use the bracket notation. So person, square brackets, the name of the target property as a string. Earlier I told you that we use the bracket notation when we don't know ahead of time, at the time of writing code, what property we're going to access. Perhaps the name of the target property is calculated at runtime. Here is a real example. When we iterate over the properties of the person object, in each iteration, the value of key is going to be different. So here we can use the dot notation to display the value of this property. In other words, we can do something like this. Because we don't have a property called key in the person object. So that's when we use the bracket notation. So we add square brackets and pass key as the name of the target property. Now let me delete this stuff here, save the changes. So you can see the value of name is Mosh and the value of age is 30. So this is the for in loop, and we use it to iterate over the properties of an object. We can also use this to iterate over an array, but it's not an ideal way. In the next lecture, I'm going to show you a better way, but let's see how that works before we finish this lecture. So I'm going to define an array called colors with 3 values, red, green, and blue. Now we can use the for in loop to iterate over this array. So for let index in colors, note that I named this loop variable index because in each iteration, this index variable will be set to the index of one of the elements in this array. So it's going to be 0, 1, and 2. Let's take a look. So console.log index. Save the changes. So we get 0, 1, and 2. Now, if you want to get the element at the given index, once again, we use the square bracket notation. So, comma, colors of index. Save the changes. And now we can see each element in our colors array. Now, starting from ECMAScript 6 or ES6, which is the modern version of JavaScript, we have a new kind of loop that is called for of loop. And that is an ideal way to iterate over arrays. And that's what you're going to learn in the next lecture. So as I told you in the last lecture, starting from ECMAScript 6 or ES6, we have a new way to iterate over arrays. And that is using the for of loop. It's very similar to the for in loop, but instead of the in keyword, we use the of keyword. So here's an example. For let color of colors, we can simply log this color on the console. You can see with this new for loop, we don't have to deal with this index, and we don't have to access the element at the given index. So in each iteration, this color, which is our loop variable, will hold one of the items in this array. So when I save the changes, we see red, green, and blue. So I'm going to delete this for in loop, bring the colors array down to summarize everything. So we use the for in loop to iterate over the properties of an object, and the for of loop to iterate over the elements or items in an array. With all the loops you have learned about in this section, there are 2 keywords, break and continue, that can change how the loop behaves. In this demo, I'm going to use a while loop, but what you're going to learn applies to all kinds of loops you have learned in this section. So let's start by declaring a variable called I and initialize it to 0. Now we put this in a while loop, as long as I is less than or equal to 10, we want to display I on the console and then increment it. Save the changes. So this gives us numbers 0 to 10. Now sometimes you want to jump out of a loop for some reason that may happen at runtime. For example, here we can have an if condition, an if statement with a condition like this. If I equals 5, we want to jump out of this loop. That's where we use the break keyword. Now when we save the changes, see what happens? We get the numbers 0 to 4. So at the end of the 5th iteration here, we increment I. Now I is 5, so we break out of the loop. Now let me comment this out and look at the continue keyword. So I'm going to write another if statement. I want to see if I is an even number or not. So I modulus 2 equals 0. If that's the case, I want to increment I and then continue. Let's see what happens when we run this code. Save the changes. We only get the odd numbers. Why is that? All right, let's take a look at an example. So when I becomes 2, it's an even number. At this point, we increment I, so I will be 3. Now, when the JavaScript engine sees the continue keyword, it will jump to the beginning of the loop and continues execution of the next iteration. At this point, I is 3, so this if statement is not executed, and that's why we see I on the console. Now, in my personal experience, continue is not something that you would use that often. It's one of those old legacy things in the JavaScript language. I'm only explaining it here in case you see it in projects that you're working on. But it's not something that I recommend you to use. It's an ugly way of writing code. So just to recap, with the break keyword, we jump out of a loop, and with the continue keyword, we jump to the next iteration. All right, here's an exercise for you. I want you to write a function that takes two numbers and returns the maximum of the two. Call that function, give it different arguments, and make sure it's working properly. So pause the video, do this exercise, and when you're done, come back, continue watching. I'm going to start by defining a function, call it max. Here we need two parameters. We can call them number 1 and number 2, or we can use shorter names like A and B. Now earlier I told you not to use mysterious variable names like A and B. But in this particular case, it doesn't really matter because A and B are kind of self-explanatory. So we're not dealing with a complex logic. We don't have to guess what A and B are, as you will see in a second. So in this function, we want to have some logic. We want to compare the value of A with B. So we're going to use an if statement. So if A is greater than B, we want to return A. Else, we want to return B. That's the simplest implementation. It's not the best way. We're going to optimize this step by step. But before going any further, let's make sure that this function actually works. So I'm going to declare a variable called number and set it to max of 1 and 2. Now let's display number on the console. Save the changes. So max is 2. So if the second argument is greater, our function works. What if the first argument is greater? So let's change 1 to 3. Save. Now we see 3. Perfect. What if both arguments are equal? Once again, save the changes. We still see 3. Perfect. Now before going any further, did you notice how I called this function with different arguments? I called it with different test cases. First, I assumed if the second argument is greater, then I assumed if the first argument is greater, and finally I assumed that both arguments are equal. So when writing code, when writing functions, you should test your functions with different possible values, okay? Now, let's get back to this max function and clean up this code. The first thing I want to improve here is to remove this else keyword. Why? Because if A is greater than B, we're going to return A, so we'll jump out of this function. So none of the code after line 6 will be executed. In fact, we will never get to this point. So we don't really need the else keyword, okay? So if A is greater than B, we'll return A. Otherwise, will return B. So this is a cleaner implementation. But hey, we can make this even cleaner. So earlier you learned about the conditional operator. Remember this? So we had a condition in parentheses, question mark. If this condition evaluates to true, we use one value, otherwise we use the other value, right? We can rewrite these two lines using our conditional operator. So what is the condition here? If A is greater than B. If this condition is true, we want to return A, otherwise we want to return B. All we need here is a return statement and terminate this with a semicolon. So this line is exactly equivalent to these two lines. Now, save the changes. Both arguments are equal. We get 3, so far so good. Let's try another test case. I'm going to make the first argument larger. Let's say 5. We get 5. Now let's make the second argument larger, 10. Beautiful. So our function is working. Here is another exercise. I want you to implement this function. Function is landscape. It takes two parameters, width and height of an image, and returns true if the image is landscape, which means width is greater than height. Otherwise, it returns false. Now, you may think this is similar to the exercise from the last lecture. In fact, it is, but I want you to do this exercise because I'm going to give you a simple and effective tip to write better code. So pause the video, do the exercise, and then come back, continue watching. All right, so similar to the last lecture, we can start with a simple if and else. So if width is greater than height, we want to return true. Otherwise, we want to return false. But I told you that in this case, we can use the conditional operator. So we add the condition. If width is greater than height, we can return true. Otherwise, we'll return false. And here's our return statement, right? So here's the implementation of this function. However, code like this looks very amateurish. You don't want to return true or false explicitly. This is very ugly. Why? Well, let me show you. We can completely delete this part here and simply return the value of this expression. So if width is greater than height, this expression will be evaluated to true. So we'll simply return true. Otherwise, if width is less than height, this expression will evaluate to false, so we'll return false. So there is really no need to explicitly return true and false here. That's a poor way of writing code. So now we have this function. Let's test it. We can do a console.log. Simply call this function here is landscape. I'm going to pass these dimensions 800 by 600. So we expect true on the console. Save the changes. Here's true. Beautiful. Now let's change the width to, let's say, 300. Now we have a vertical image. Save. So we get false. This next exercise I want you to work on is a very popular interview question called the fizz-buzz algorithm. So we have this function called fizz-buzz. We give it an input and it returns a string. Let me show you how that works. So let's declare a constant called output. Here we call fizz-buzz and pass an input like 3. Then log the output on the console. Let's see what we get. We get fizz. So if the number that we pass in is divisible by 3, we get fizz. So let me show you here. If the number is divisible by 3, we get fizz. Now, if the number that we pass is divisible by 5, we get buzz. So divisible by 5, we get buzz. Now, if the number that we pass in is divisible by 3 and 5, like 15, we get fizz buzz. So divisible by both 3 and 5, we get fizz buzz. Now, if the number is not divisible by either 3 or 5, we're going to get the same number. So if we pass let's say 7, we get 7. So not divisible by 3 or 5, we get the same input. Now, if we don't pass a number here, let's say we passed a string, we should get this message, not a number. The same is true if we pass a Boolean or anything that is not a number. So if the input is not a number, that is the message that we should display on the console. So I want you to pause the video, spend 10 to 15 minutes on this exercise, and when you're done, come back, continue watching. All right, let's see how we can implement this fizzbuzz function. So we get the input. First, we want to see if this is a number or not. Because if it's not a number, then we don't care about dividing that number by 3 or 5. So for that, we use the type of operator. So if type of input is not number, we want to return this message, not a number. So that's the first if statement in this function. Now, if we get to this point, that means we have a number. We want to see if this number is divisible by 3, 5, both of them, or none of them. We can write an if statement like this. If input modulus 3 equals 3, that means this number is divisible by 3. So we return fizz. Similarly, we're going to have another if statement. So if input modulus 5 equals 0, we're going to return buzz. Next, we want to see if this number is divisible by both 3 and 5. So if input is divisible by 3 and input is divisible by 5 as well. Now here we're dealing with a complex expression. To make this code more readable, I would like to put each expression in parentheses, like this. So here we have one expression, then we have the logical and the second expression. We can select this expression and type the opening parentheses, and this automatically adds the closing parentheses. That's a quick tip for you. So if this number is divisible by both 3 and 5, we want to return fizz buzz. And if we get to this point, that means that number is not divisible by either 3 or 5. So we simply return the same input. Now let's test this function. So initially I've passed false. We should get not a number on the console. Save the changes. We get not a number. Beautiful. What happens if we pass 3? We get 3. What happens if we pass 5? We get buzz. So far, so good. What if we pass 15? 15 is divisible by both 3 and 5, so we should get fizz buzz. Save the changes. Wait a sec, what happened here? We got fizz, whereas we expected fizz buzz. The reason for that is because of how we have ordered our if statements. So in this case, 15 is divisible by 3, so this if statement is executed, and here we immediately return fizz. To solve this problem, we need to move this if statement on the top. So I've selected these two lines. Now to move this code up, we can simply press the Alt key and the up arrow. As simple as that. Okay, so if the number is divisible by both 3 and 5, we immediately return fizzbuzz. Now, let's save the changes. Okay, the problem is solved. What if we pass a number that is not divisible by 3 or 5? Let's say 7. Now we get the same input. Beautiful. So this is the fizzbuzz algorithm that you see in a lot of programming interviews. Now I want to show you something. In JavaScript, we have this special value called not a number. So here I'm going to replace this string with not a number. Whenever you're dealing with some mathematical calculation, if the result is not a number, this value is returned. So we can use the same value instead of returning a string like not a number. Now, this was not part of the exercise. It's something that I'm teaching you now. So let's save the changes. Now, instead of passing a number, let's pass false. Now we get not a number. Let's take a look at the type of this value. So type of, not a number. Weirdly enough, the type of this value is a number, but the value is something specific that is not a valid mathematical number. All right, here's another exercise, but this exercise is a little bit more complicated than the earlier exercises. So I want you to implement this function, check speed. This function takes a parameter that's the speed of a car. Now in this program, I'm assuming that speed limit is 70 kilometers an hour. So if a car is driving under the speed limit, we get this OK message on the console. Similarly, if we pass 70 here, so if somebody is driving exactly at the speed limit, they're still good. We still get the OK message. Now for every 5 kilometers above the speed limit, they're going to get 1 point. So if I drive at 75 kilometers an hour, I get 1 point here. But what if I drive at 72 kilometers an hour? I'm still good. So for every 5 kilometers above the speed limit, we should give the driver 1 point. Now, as part of calculating the point here, you'll have to use one of the built-in functions in JavaScript. That is math.floor. We can give this function a floating point number, like 1.3. Let's say 1.3 points. And this will convert that to the greatest integer. For example, if we go in the console here and type math.floor of 1.3, we get 1. So you will have to use this function as part of your calculations, okay? Here is a tip for you. Now back to our check speed function. What if we pass 80 here? We should get 2 points, right? So we get 2 points, beautiful. Now what if we drive at 180 kilometers an hour? Our license is suspended. So if a driver gets more than 12 points, then their license should be suspended. So here's the logic for this function. I want you to spend 15 to 20 minutes to do this exercise. Once you're done, come back, continue watching. All right, now let's see how I solve this problem. So let's define a function called check speed. It takes this speed parameter. Now first we want to see if the speed is less than the speed limit. So here's a simple if condition. If speed is less than 70 kilometers an hour. We want to display console.log. Okay. Now the first thing I want to improve here is to turn this magic number into a constant, because someone else looking at this code may not know what 70 represents here. So you should avoid using magic numbers in your code. Always use constants to describe them. So here we can define a constant. Speed limit, we set it to 70, and then replace this magic number with speed limit. With this change, now our code is more expressive, and also, if you want to use this number somewhere else in this function, we don't have to repeat it multiple times. We have defined it here once, and we can reuse it in multiple places. If tomorrow the speed limit changes to, let's say 75 or 65, there is only a single place that we have to change, okay? So if the speed is less than the speed limit, we display OK. Otherwise, we should calculate the points. So here we need a simple calculation. We want to get the speed, subtract it from the speed limit, and then divide the result by 5. Because for every 5 kilometers above the speed limit, we should give them 1 point. Now, once again, we don't want to use this magic number here. It's not descriptive. So we want to turn this into a constant. So let's define another constant. We can call this kilometer per point and set it to 5. And then replace this magic number with km per point. So with this, we get the number of points that we should give to this driver. Now, the result of this expression can be a floating point number. So earlier I told you to use math.floor to convert that floating point number to the greatest integer. So here, we can call math.floor And as an argument, we pass this expression here. So this is how we calculate the points. Now we should check to see if the driver gets more than 12 points. So we need another if statement. If points is greater than or equal to 12, we want to suspend their license. So console.log license suspended. Otherwise, we want to display the number of points on the console. So console.log points. And as a second argument, we pass this points variable. Now, technically here, I could also use a constant, and that's a better practice to make sure I don't accidentally modify these points here. So we change this to a constant. And if we accidentally try to modify points like this, we're going to get an error. Okay? So as I told you before, const or constant should be your default choice. If you want to reassign a variable, that's when you use the let keyword. Now let's test this program up to this point. So on the top, I'm going to call this function check speed and pass 50. Save the changes. We get OK. So far, so good. What if we drive exactly at the speed limit? That's weird. Instead of getting 0 points, we should get the OK message. So there is a bug in our condition here. So if speed is less than or equal to speed limit, we should get the OK message. Save the changes. Now the bug is solved. What if we drive 1 kilometer above the speed limit? Notice all the test cases I'm going through for this exercise. It's very important that when you write a function, test it with different values. So if we call this function with 71, what should we get here? We should still get the OK message instead of 0 points, because starting from 75, we should get the first point. So let's save the changes and see what we get. We got 0 points. So we still have a bug in this function. Well, we should actually change this condition to something like this. So we want to get the speed limit, in this case 70, at kilometer per point. So that would give us 75. If we drive less than 75, we're still good. But from 75 kilometers an hour or faster, we should get a point. So let's save the changes. At 71 kilometers an hour, we get the OK message. Beautiful. What if we drive at 75? We should get 1 point. So here's 1 point. What if we drive at 70, let's say 7 kilometers an hour? We should still get 1 point. So save the changes, 1 point, beautiful. What if we pass 80 here? We should get 2 points. There you go. Now to get 12 points, we have to drive 12 times 5, which is 60 kilometers above the speed limit. So if we pass 130 here, we should get 12 points and our license should be suspended. Save, license suspended. Beautiful. So our function is working. I just want to show you one more tip to make this code cleaner. So here we have this else block, and this has caused indentation here. Now, this is not a terribly bad thing, but it's better to avoid indentation if we can, because otherwise we have to scroll to the left and right to see what's happening here, right? So if this condition is true, we want to display OK on the console. Now, to get rid of this else block and the indentation, we can add a block here, display OK on the console, and then return. So with this, we'll jump out of this function and none of the code here will be executed. So with this, we can delete this else statement as well as the code block and remove the indentation. All right, here's your next exercise. I want you to write a function called showNumbers that takes a parameter called limit. So we pass a number here like 10, and when we call this function, we should see all the numbers from 0 to the number we supplied as the limit. Now next to each number, if that number is even, you should display the even label, otherwise you should display odd. It's a fairly easy exercise. Pause the video, spend a few minutes, and when you're done, come back, continue watching. So here we need a for loop. We set our I variable to 0. And as long as I is less than or equal to this limit, we're going to run this loop. And in every iteration, we'll increment I. Now here we need to check if I is an even number or not. So if I modulus 2 equals 0, we display console.log of I, and as the second argument we pass even. Otherwise, we do a console.log of I and odd. Now there is another way to write this program. So instead of having two separate console.log statements, we can do something like this. We can declare a constant, call it message. And here we can use the conditional operator. So if I is an even number, we set message to even, otherwise we set that to odd. Next, we do a console.log of I and message. I find this second implementation cleaner and less noisy, but if you use the first implementation, that's perfectly fine as well. Now, save the changes. We get all the numbers from 0 to 10. In this exercise, I want you to create a function called countTrueC, which takes an array and returns the number of trueC elements in this array. Now, what are these trueC or falsy values? Let me quickly refresh your memory. Sometimes when we have an if statement, we might pass a Boolean true or false as the condition here. For example, we might have a constant called isActive. We set this to true. And when we use this constant as the condition here, we get this hello message on the console because this is a Boolean true. But sometimes what we have in our if statement is not necessarily a Boolean value. It could be a string, it could be a number, it could be an object. So the JavaScript engine tries to convert that value to something that is like a Boolean, but it's not a Boolean. Here's an example. Let's say I have a constant called name. I set this to this string, mosh. Now, if I pass name here, obviously name is a string. It's not a Boolean true or false. So the JavaScript engine tries to interpret this as trueC or falseC. So when we run this code, you can see we still see the hello message because we're dealing with a string of characters. So this is what we call a trueC value. It's not the Boolean true, it's trueC. In contrast, if we had an empty string, JavaScript engine would see this as falseC. Again, it's not the Boolean false, it's falseC. Now, when we run this code, we no longer see the hello message. So that's all about trueC and falseC values. Now, let's quickly review the list of falseC values in JavaScript. So, undefined, null, empty string, the Boolean false, 0, and not a number. You learned about this value in an earlier exercise. That's something that I forgot to mention when I talked about all the falseC values in JavaScript, but this is the complete list of falseC values in JavaScript. So now your job is to create a function called countTrueC that gets an array and returns the number of trueC values in this array. So here's an example. If I declare this array and set it to 1, 2, 3, so here we have 3 trueC values. We call countTrueC, pass this array, and immediately pass the result to console.log. Now save the changes, so we get 3 here. Now if we add 0 here, because 0 is a false value, we still get 3. If we add null, undefined, and empty string, we still get 3. If I remove one of these numbers, let's say 1, we get 2. So go ahead, do this exercise, and when you're done, come back, continue watching. All right, to count the number of trueC values, first I'm going to declare a variable called count and initialize it to 0. Now we need to use a for-of loop to iterate this array, and for each element, we need to check to see if that element is trueC or not. If it's trueC, we're going to increment count. So for let value of array. Now, if this value is truthy, we simply increment count. And finally, we return this count. That's all the code you had to write. So note that here, I'm not comparing this value with all those falsy values. In other words, I didn't write code like this. If value is not false or value is not undefined, this is a very poor way of writing this code. We don't want to have 5 conditions here for every falsy value. We simply pass that value here. Now that value might be a Boolean or a non-Boolean. If it's not a Boolean, the JavaScript engine tries to interpret it as truthy or falsy. So if the result is truthy, then count will be incremented. As simple as that. All right, here's another simple but great exercise. Your job is to create a function called showProperties. We pass an object here, and this function should display all the properties of this object that are of type string. Let me give you an example. So on the top, I'm gonna define an object like movie. We use the object literal syntax to initialize this. So here we're gonna add a few properties like title. We set it to a simple string. The value doesn't really matter. A is enough. Release year, we set it to a number like 2018. Rating, again, a number. And then director, we set it to another string. Now, if we call this function showProperties and pass this movie object, see what we get. We see the string properties of our movie object. So title is A and director is B. So pause the video, do the exercise, and when you're done, come back, continue watching. All right, here we need to use the for in loop to iterate over the properties of this object. So for let key in object. So in each iteration, this key will hold the name of one of these properties. Let's have a quick look here, console.log of key. So we get title, release year, and so on. Now we need to get the value of each of these properties and then check the type of that value. If the type is a string, then we'll display the property and its value. So to get the value of this property, we use the bracket notation. So object of key. Now to check the type of this value, we use the type of operator, and then we put this in a if statement. So if the type of object of key equals string, then we simply display the key as well as object of key. Save the changes. We only get the title and director properties. That's something I need to emphasize here. You might be wondering why I didn't use curly braces here, because we have 2 lines under this for statement. Well, accurately, we have only a single statement under this for statement. So this console.log is a single statement that belongs to our if statement. So here we don't really need curly braces because we're dealing with a single statement under the for statement. But if you prefer to put the curly braces here, that's perfectly fine. So let me show you. It looks like this. It's more of a personal preference. Here's another simple but great exercise that trains your programming brain. So I want you to create this function called sum. We give it a limit, and this function will return the sum of all the multiples of 3 and 5 from 0 up to this limit. Here's an example. What are the multiples of 3 and 5 between 0 and 10? Well, multiples of 3 are 3, 6, and 9. And multiples of 5 are 5 and 10. So I'm including this number that is passed as a limit. Now, if we add these numbers together, the result will be 33. And that's the job of this function. So save the changes, we get 33. Here we need to start with a for loop. So for let I equal to 0, As long as I is less than or equal to limit, we want to increment I. Now we need to check to see if I is a multiple of 3 or 5. So if I modulus 3 equals 0, or I modulus 5 equals 0, now we need to take I and add it to our sum. So here we need to declare a variable, sum, set it to 0. And if I is a multiple of 3 or 5, we need to add I to sum. And finally, we return sum. Now pay attention to how I have formatted this code. I've added these extra vertical line breaks to separate the initialization from the actual logic from the return value. If we didn't have these vertical breaks, this code would look a little bit squashed. It's a little bit hard to read. So as a best practice, it's always good to separate the last line, the return statement. Now in this case, we can have all these lines together because they're highly related. So we start with initializing sum to 0, and now we're still working on sum to add something to it. However, some developers prefer to separate the initialization, so you could add a line break here as well. That's more of a personal preference. But what I want you to take away is that lines that are highly related should be together, and they should be separate from other lines. In this exercise, we want to calculate the grade of a student. So here are the marks of a student in different subjects. We pass this array to this function, calculate grade. What this function does is first it calculates the average grade. So what is the average here? 80 plus 80 plus 50, that comes to 210 divided by 3, so the average is 70. Now here we need a table to see what grade this average corresponds to. So if the average comes down to this range 1 to 59, the grade should be F. If it is between 60 and 69, that should be D. If it's between 70 and 79, that should be a C. If it's between 80 and 89, that should be a B. And finally, if it's between 90 and 100, that should be an A. So spend 5 to 10 minutes on this exercise. When you're done, come back, continue watching. All right, here first we need to calculate the average mark. So to calculate the average, first we need to declare a variable like sum, initialize it to 0. Then we need to use the for of loop to iterate this array of marks and calculate the sum of all these marks. So for let mark of marks, we get mark and add it to sum. So sum plus equals mark. So this is the total. Now to get the average, we need to divide sum by the number of marks, that is marks.length. Now we have the average. We need to use this table to map it to a grade. So one way to calculate the grade is like this. So if average is greater than or equal to 0, actually here the range should be 0 to 59. So if average is greater than or equal to 0 and average is less than or equal to 59, we're going to return F. And similarly, we can have a few other if statements for other grades, but this code is a little bit ugly. There is so much noise in this code. Instead of having two conditions along with the logical AND, we can simplify this expression to something like this. If average is less than 60, because the range for F is 0 to 59. So as long as average is less than 60, we get the same result. See what I did here? So there are different solutions to solve a programming problem, and you should aim for the simplest solution, because as Leonardo da Vinci says, simplicity is the ultimate sophistication. So using this pattern, I'm going to calculate the other grades. So if average is less than 70, return D. Because if we get to this point, that means average is at least 60 or higher. Now I'm just checking the upper limit. So the upper limit should be 69. So if the average is between 60 and 69, we return D. Similarly, if the average is less than 80, we'll return C. If average is less than 90, we'll return B. And if we get to this point, that means the average is at least 90 or greater. We don't really need another if statement here. We can simply return A. Now we can make this code even better. While this function is fairly simple, it's only about, I don't know, maybe 10 lines of code. We can break this function into two smaller functions, each focusing on one thing. That is what we call single responsibility principle. I use a metaphor. Think of a restaurant. People working in a restaurant have different roles. So the chef is in the kitchen, responsible for cooking. The chef doesn't come out and take orders. So he or she is responsible only for one thing. The same goes for the manager. The manager is responsible only for one thing, managing the restaurant at a high level. We have the same concept in programming. So we should have functions that are small and are focused only on one thing. In this function, we are basically doing two different things. The first part of this function is all about calculating the average of numbers in an array. And the second part is about mapping that average to a grade. So we can extract these few lines, put them in a separate function like this. So function, calculate average. We give it an array. This array can be anything. It can be an array of marks, or it can be an array of temperatures, anything. We can reuse this function in the future whenever we need to calculate the average of a bunch of numbers. Now, I'm going to get all this code, cut it, put it here. Now here we need to rename a couple of variables. Here we're working with marks, but the parameter of this function is called array. So put the cursor here, press F2 and rename this to array. Also, we need to rename our loop variable from mark to value. So now we have a generic function. It's not tied to marks. It can be reused in different situations. And finally, we can return the average here, or we can make this code even simpler. So instead of storing the average in a variable and then returning it, we can simply return the result of this expression. So return sum divided by array.length. See? And finally, we can reuse this function here. So we declare a constant, average, and set it to calculate average of marks. With this change, now we have two very simple functions. Each function is responsible only for one thing. This exercise is a very popular exercise for junior programmers. So we have this function, show stars, with a parameter called rows. So when we call this function and pass 5, see what we get on the console. We get 5 rows. In each row, we have a star, and the number of stars in that row depends on the row we are in. So in the first row, we have 1 star. In the second row, we have 2 stars, and so on. If we call this function, pass 1, we get only a single star. If we pass 2, we get 2 rows. If we pass 10, you got the point. So go ahead and spend 5 to 10 minutes on this exercise. When you're done, come back, continue watching. All right, here we need to start with a for loop. So for let row, we set this to 1. As long as row is less than or equal to the number of rows, we want to increment row. Now in each row, depending on the number of row, we need to display 1 or more stars. So here I'm going to declare a variable. Let's call it pattern. We set it to an empty string. Now, depending on the value of the row, we need to add 1 or more stars to this pattern. So here we need another for loop for let. Let's call this I. We set it to 0. As long as I is less than row, we increment I. And here, we add a star to the pattern. So plus equals star. So if you're on row 5, This loop will execute 5 times because we started from 0, and we run this while I is less than row. So this will execute 5 times, and each time we'll append 1 star to our empty string. So we'll end up with 5 stars. And finally, when we're done with this loop, we do a console.log of pattern. That's all we have to do. Now on the top, I'm going to change this to 5, save the changes. The algorithm works beautiful. If we pass 1, we get 1 star. If we pass 2, we get 2 stars. So what we have here is what we call a nested loop. So we have a loop inside of another loop. And you may see this pattern in a lot of algorithms. And finally, your last exercise for this section. I want you to create this function, show primes, that takes a limit and shows all the prime numbers up to this limit. So here are the prime numbers that we have up to 20. We got 2, 3, 5, 7, and so on. In case you don't know what's a prime number, let me give you a brief explanation. So in mathematics, numbers can be prime or composite. A prime number is one whose factors are only 1 and itself. So it cannot be divided evenly into another number. Let me give you an example. Think of 12. What are the factors of 12? Well, we got 1, 2, 3, 4, 6, and 12. These are the factors of 12. So when we divide 12 by these numbers, we won't get any remainder. The remainder will be 0. So we say 12 can be divided evenly by its factors. Now 12 is a composite number because it has many factors. A prime number, in contrast, has only 2 factors. It's 1 and itself. Here's an example. So we got 11 here. The factors of 11 are 1 and 11 itself. The same is true for 13. It can only be divided evenly by 1 and 13. So go ahead and create this function. You will see my solution next. To implement this function, we need a for loop that starts from 2 up to this limit, because the first prime number is 2. So for let I, we set it to 2, as long as I is less than or equal to limit I plus plus. Now for each number, we need to check to see if this number is prime or not. So we need another loop here that starts from 2 all the way to the current number, that is I. With this nested loop, we can see if I has a factor other than 1 and itself. So let's define another for loop. Now what should we call this other loop variable? We cannot call this I because we have already defined I here. So one way is to call this J, but someone reading this code, they don't know what is I, what is J. It's confusing. So always pay great attention to the name of your variables. What I is essentially representing here is a number. So the outer loop is for iterating numbers from 2 to this limit. So let's call I number. We press F2 here and rename it to number. Now what is this inner loop for? That is for finding the factors of that number. So instead of calling the loop variable J, we can call it factor. So factor, we set it to 2. As long as factor is less than this number, we want to do factor plus plus. Let me expand this a little bit so you can see. All right, now, if this number can be evenly divided by its factor, so if number modulus factor equals 0, that means this number has a factor other than 1 and itself. That's why I have not included 1 in this loop, because of course, every number can be divided by 1. For the same reason, I have not included the number itself in this loop, because again, we know that each number can be divided by itself evenly. So in this inner loop, we want to see if we have a factor other than 1 and the number itself. So if we do, that means this number is not a prime number. So basically what we can do here is declare a variable, call it is prime. We can assume that this number is a prime number, But if this condition is true, then we need to set is prime to false. Also, if we get to this point, there is really no need to continue this loop, because let's imagine we want to display all the prime numbers from 1 to billion. Now, in this inner loop, as long as we find a factor for this number, that means this number is not a prime number. So there's really no need to continue running this loop, because this is just wasting our computer's processing power. So here we can add a code block, put is prime here. If we get to this point, we can use the break keyword to jump out of this loop. Okay? Now, when we get to this point, is prime is either true or false. If it is true, we log this number on the console. Save the changes, we get this result, beautiful. If we pass 10 here, we get all the prime numbers from 2 to 10. Now here's another challenge for you. Earlier I told you about the single responsibility principle. We want to have small functions, each function responsible for a single task. So I want you to modify this code, extract a new function, make sure each function is small and responsible for a single task. So pause the video. When you're done, come back, continue watching. So if you look at the lines 7 to 11, all we are doing here is checking to see if a number is prime or not. This logic does not necessarily have to be part of our show primes function. We can have a separate function called is prime that takes a number and simply tells us if this number is prime or not. Then we can use this function inside of show primes function or somewhere else. So it's a reusable function. It's a reusable piece of code. So I'm going to extract all these lines, move them to our new function. Now we can make this code cleaner and more elegant. So if we get to this point, instead of breaking from the loop, we can simply return false. In other words, there is no need to break and then return is prime. We can do a shortcut here. So if we get to this point, we simply return false. That means we don't need to set is prime to false. We don't even need to declare is prime. So we run this loop. We try to find a factor for this number. If we find a factor, we immediately return false. Otherwise, if we get to this point, that means we didn't find any factors for this number, so we return true. Also, we can get rid of all these curly braces because our for statement, our for loop has a single statement, and our if statement also has a single statement. So let's get rid of all these extra curly braces getting in the way, annoying me. Okay, that is better. Now finally, in show primes, so here we have only a single loop. We are iterating the numbers from 2 to this limit. We simply call is prime function and pass our number. If the number is prime, we log it on the console. This also means we don't need these curly braces. And here's the end result. With these changes, now we have two very simple functions. If you give this function to the dumbest person in the world, they won't understand it. Also, we don't have nested loops. Generally speaking, nested loops are a bit hard to understand. So whenever you have a nested loop, that's probably an indication that you can extract the logic in the inner loop and put it somewhere else in a different function. So that brings us to the end of this section. I hope you enjoyed the materials and thank you for watching.